All right, so let's go over those answers. It's more of a review of all four sections of chapter 7 that we've gone over. So is number 1 growth or decay, or it's 3 we started, right?
Yeah.
Growth or decay, Alex? It's growth, right. How do we know if it's growth? What's above 1? The number in front is the base, right? How do we know if it's decay? Yeah, between, it's lower than 1, but it's still bigger than 0, right? Between 0 and 1, right? It's not negative. Okay? So you should be able to recognize if it's a growth or a decay problem. Number 6. Is that exponential or not? Sydney?
I said yes.
Yes, because the variable is where the exponent is, right? If the exponent is a number like you're used to, then it's not exponential. So you should be able to recognize if it's exponential or not. Again, you probably won't get quizzed on that, though. Number 9, inverse. Okay, what's the inverse for number 9, Cade?
X over 15.
Right. All you have to do for inverses. Now remember, f of x we think of as y equals, right? You with me on that? So all we have to do to find the inverse is switch the x and the y. Okay? So this becomes x equals 15y. So what do I have to do to get y by itself? Move the 15 over. How do I move it? Divide. Okay? So the inverse, all right, f inverse, that's the symbol, is x divided by 15. Okay? That's all you got to do for those. You should remember how to do that. Number 12, same thing. Olivia Carr, what'd you get?
I love it, I kind of feel the 3.
That is correct. X minus 2 over 3. Does anybody need to see number 12? Do the same thing. Write it as x equals 3y plus 2, and then just solve for y. Okay? 15 was a graph, I think. It said graph the function. We're not going to worry about that, so we'll just skip it. You guys know how to graph a linear function with slope and y-intercept. So 18, it's 3 to the 5th equals 243. That's an exponential function or equation. You have to write it in logarithmic form. Okay? Coli, what is that in logarithmic form?
Log.
Base what? What's the base?
3.
Yeah.
The 2.
Not to the of 243.
43 equals 5.
Right. All right. You should understand that the 3 is the base, the 5 is the exponent, 243 is the number. So log base 3 of the number equals the exponent. That's what logs are. They're exponents. Okay? You're supposed to be able to do that. 21, we got 7 to the x power equals 343. Kennedy, what's that in exponent or logarithmic form?
Log 7 343.
Very good. Okay? 24, I think it's going the other way, isn't it? Giving you a log and you have to write it exponentially. Yeah, log base 4 of x equals 70. an exponent problem. Yeah, that's a big exponent, but that's right. Okay? Just going the other way. Should be able to do both of those. Those are easy problems. So when we have the quiz Friday, you shouldn't miss those. All right, 27, log base 5, I believe that is, so 0.2. So small in my book. You can hardly see it. Okay? I think it says use mental math, but we don't need to do that anymore, do we? So how do I put that in my calculator? How about Andrew?
I can't do it. I don't know.
You don't know?
No,
Why don't you?
I don't know. I never did it myself.
Well, it's time.
I can't do it online.
Yes, you can.
No. I really can't.
Yes, you can.
No.
Quit being a sissy. Sophomore sissy.
And the
So what do we hit?
log 5.
Oh, you're killing me.
I don't know.
The 5, the base goes in the basement.
The
So
0.2.
0.2.
Then finish the,
Yeah. Close it up. Very good.
okay, and then divided by log 5.
There you go.
Yeah.
All right. So what did you get?
-1.
That is correct. Okay. Some of you are missing that because you're not closing this off. When you hit log button, when you hit log, well, you guys can see, and it's in your other, it doesn't have to be the graphing calculator for this one, for these. But when you hit log, it gives you that parenthesis. So you have to close it off before you hit the division problem, the division sign, okay? So make sure you put it in right. So this should be really easy the rest of the way. Is number 30 another graph one? Yeah, it's another graph one, right? They told you to put -2, -1, 0, 1, 2 in for X. And then, describe domain and range. Domain is what values? X, ranges Y. You guys know that stuff, right? So again, I'm not worried about having problems like that on the quiz. So we're down to 33. Okay, we have an addition problem. Log base 4 of 8. Plus log base 4 of 2. So what's the property? What's the rule that we learned? How do you make that a single log? Multiply what? 8 and 2, yes. So that's what I'm looking for on the quiz. In the practice quiz, write the problem as a single log. Don't just give me the answer. That's if you have one log and the 4 is the same. If it's log base 4 of 4, then yeah. All right, so then we just do what to simplify it now? Sammy Joe? Yeah, so what is that thing? Right, just do this then. Now, some of you are getting good at this. You could tell me that the answer is 2 in your head, and that's fine. Okay? But to get full credit on this type of problem on the quiz, I want to see the single log and the answer. Okay? Don't just give me 2. All right? Because that means you're just putting it in, the whole thing in the calculator. All right? I want you to understand that an addition problem you can simplify to a single log. That's what the calculator will say. When you put it in the calculator. But again, if we were doing this mentally, This means 4 to what power is 16? 4 to the second power is 16,
Oh, okay.
right?
I was thinking 16.
Yeah, you're not going, it's the log now. It's not just 16 divided by 4. It's the log of 16 divided by 4. Where are we at, 36? 36 says we have a subtraction problem, log of 10,000 minus log of 100. All right, so how do I turn that into a single log? Cole Everly. Well, since we did addition problem just now, we multiplied the two numbers. Yeah, you're going to divide the two numbers. Okay? So what is 10,000 divided by 100? It's 100, isn't it? Now, if it's got no base, you don't have to put log of 100 divided by log of 10. You just hit log of 100. Because, what do we call this one? That's a common log. That's your log in the calculator, the base 10 one. Okay? So you don't have to put in, like I said, log of 100 divided by log of 10. All right? But if you did, that's okay. You still get 2. Okay? Number 39. Simplify if possible. So it says log base 7 of 49 to the 5th. So we got a subscript, we got a base, and we got an exponent. What rule did we learn? Yeah, take the 5, the exponent, and multiply it by the log. All right? So we can move that out front and say 5 times the log, base 7, 49. Okay? So then I can put 5 times log of 49, close it off over log of 7. That comes out to what, Grant? 2. Right, times 5. 10, yeah. All right. Questions? Andrew, you getting that thing to work or not?
Yeah,
You figuring it out?
I'm trying to figure out into the log.
You had log in there before,
I
didn't you?
know, but you have to type it in.
There's got to be a easier way. Did you try to Google it or anything?
Yeah, I did yesterday.
It still said you had to type it in?
Yeah. You have to find it on the catalog. I don't know. It's easier to just type it in.
All right, that was 39. 42 is 4 to the log base 4 of 12. So in the exponent, it's got the logarithm. This is one of the easiest problems we'll ever have. What's the answer? 12, yeah. These, if the base, if these two numbers here match, then they cancel each other out. Whatever comes after that log there is the answer. All right? That's the same as if we did, log base 3 of 3 to the 7th. What's that going to be? That's going to be 7. Right? So you'll see it may be like this, where the log's in the exponent, and that number, the base for the log and the base for the exponent are the same. It's just whatever comes after. And the same thing here. If the base of the log and the base here are the same, then they cancel. And it's just whatever that is, okay? You don't have to type it in, or you don't have to take the 7 out front and multiply. That's like a sight problem where you should be able to tell me the answer by looking at it. Does that make sense? Okay, then the last one, some of you still had question marks for this, okay? Just put it in the calculator. Max, what do I gotta put in the calculator?
Log 164 over log 4.
Yeah, just put it in the calculator, just like this. Just close stuff up, that's all. All right, so log. Oops, I got 2 logs in there. Log, there's a parenthesis, so just put 1 divided by 64 to close it. Divided by log, oh, what I hit store. Log of 4, close it. You get -3. Okay? And remember, that means 4 to the -3 power, right? If the answer is -3, 4, equals -3. So 4 to the -3 is 164. Well, that equals 1 over 4 to the 3rd, right? To make that a positive exponent, you put it in the bottom. Do the reciprocal. Is that what we talked about this week? Last week also. So 4 times 4 is 16, times 4 is 64. So it works. You want to check. Okay? Is that helping? Okay. So I have a practice quiz for you to do. We'll go over it tomorrow. The quiz will be Friday. Very similar to this type of problems we just went over.